Welcome everyone. Today we will learn how to use delegates and lambda expressions in C#. So open any C# compiler. Let's start with delegates. That basically defines a type that represents a reference to a method by defining a parameter list and a return type. So let's create a custom delegate in this program class by using the delegate keyword. Okay, add the return type and then the name of the delegate and define the parameter types. Add two parameters. Now, how to use a delegate? Basically, any method that matches the delegate signature with the same parameter types and the same return type can be referenced as an argument to another method. Let's declare two static methods with the same signature, one to sum two values at the same parameter types, and this static method will return the sum of the two values at a second static decimal method by applying the division operation, and then go to the main method and create a variable with the type of the custom delegate, which is handler, at the name of the custom delegate type, and reference any method that matches the signature. In this case, add the reference to the sum method, and we can pass this reference using the delegate type in another method. So let's add a new static method to print the value by a console by receiving the delegate type as an argument, which has the reference to a method, and then just call console.writeLine and invoke the method by passing two values. Okay, so in the main method, we just simply invoke the print method and pass the operation which holds the reference, which is the custom delegate type reference in the sum method. So let's run the console. As you can see, we have the result. You can dynamically change the method. So let's change to the division operation using the custom delegate type, and we have the corresponding result. .NET provides built-in delegate types, so we don't need to write custom delegate types. The first one is the action that basically creates a delegate with no return value, but it can receive one or multiple parameters. So let's define a built-in delegate by passing a single parameter, which will be the custom delegate type, and call this method print action, and we will call a method that matches the signature. So call the print method because it has the handler delegate type as an argument, and just simply call the print static method and the reference to this built-in delegate type. And how to use? You simply call the print action built-in delegate type by passing a method which matches the signature to the custom built-in delegate, the handler. Okay, so pass the operation which holds the reference to the division method. So let's run the application and we have the same result. Okay, but now using the built-in action delegate type without specifying any custom delegate type. Okay, so let's change the reference for the delegate type as sum to see the output is the same. The second built-in delegate we'll see is the func that basically takes one or multiple parameters and returns a value. Okay, so let's create a func, a built-in delegate, by defining two parameters, two integer parameters, and a decimal return type, which is the last type we define in the built-in delegate. Let's call sum operation and then add a reference to a method that matches the same signature with two integer parameters and a decimal return type. So let's just pass the reference to the sum method, print the result by invoking the sum operation delegate, the sum operation built-in delegate, and defining, of course, the two values. Let's run, and we have the same result. We can get rid of these sum and division methods by using an anonymous delegate. But basically, an anonymous delegate is an inline delegate without specifying any type or any method. So how to do that? In the sum operation built-in delegate, we just define an inline delegate calling the delegate keyword, defining the parameters, and then return the result, which in this case is a sum operation, okay? And we just invoke the built-in delegate type by passing the two values, print the result, and we have the same behavior by using an inline delegate. So you can see that we have too much code to write a simple built-in delegate, a simple sum operation. Here comes the concept of Lambda expressions, which is a more convenient syntax to write delegates. And we create an anonymous function to define the delegate. So let's replace this inline delegate by using an anonymous function with Lambda expressions. So we just pass the parameters, and then with a Lambda expression, we define an anonymous function that basically do the same as the inline delegate. So let's print the result. We have the same result as the inline delegate. So you can define the division operation by creating the Lambda expression, the anonymous function. For instance, you can replace this operation as division and specify the anonymous function. Let's print the result via console. As you can see, everything is good. So the last built-in delegate type that we'll see in this demo is the predicate built-in delegate, that basically it has one single parameter and returns a Boolean value. So let's use this built-in predicate delegate type to check if the operation is a sum operation. So pass the parameter type as the handler, which is the custom delegate type we created in the beginning. Then just call this built-in delegate as is sum operation, and we'll check using a Lambda expression. We'll check if the operation by passing two values, okay, is the sum of the two values. We'll check if the operation with passing in the built-in delegate type is the sum method. So we just simply call console.writeLine to print the return value, the Boolean value, by passing the isSum operation, and then the parameter will be, in this case, the operation, which holds the reference to the sum method, okay? Using the custom delegate, print the result, and it's true because the method that this custom delegate is referencing is the sum method. If we change as division, we'll check that the built-in delegate will return false. So in this demo, we've learned how to use delegates and Lambda expressions in C#.